All our lives, we've been told that the age of the universe is about 13.8 billion years. All cosmological models, from the Big Bang to dark matter and dark energy, are based on this number. Now, what if I told you that a recent article has been published suggesting that the universe might not be 13.8 billion years old, but rather 26.7 billion years old? What would you say? Were all the assumptions we've had so far wrong? Is the universe twice as old as we thought? We will explore all these topics in this video. Let me start with a question. Why have we always thought that the universe is 13.8 billion years old? Well, since the Big Bang Theory was proposed in the 20th century, scientists have estimated the age of the universe using cosmic microwave background radiation, or CMB, and the rate of the universe's expansion. The results also showed a number close to 13.8 billion years for the age of the universe. Of course, there was a time when scientists estimated the age of the universe to be between 9 and 20 billion years. But when they were able to refine it to 13.8 billion years, it was a significant achievement. But recently, discoveries from the James Webb Space Telescope have captured images of galaxies in the early universe that are much larger than they should be. And this is where scientists and physicists became suspicious and took a step back to see if all their previous assumptions and evaluations about the age of the universe were correct or not. Let's delve a bit deeper into this topic. The story began when the James Webb Telescope observed galaxies that had formed only 300 to 500 million years after the Big Bang. But the problem was that these early galaxies shouldn't have been so large. This means that these galaxies had grown much faster than we thought. Of course, this doesn't make sense logically. Because according to current models, galaxies need billions of years to grow to this size. This means something is wrong. This is where Rajan Gupta, a physicist at the University of Ottawa, Canada, presents an even stranger scenario. A revolutionary and shocking idea that suggests the universe might be older and more ancient than we think. In fact, this physicist in his article examines the idea that instead of saying our models about galaxy formation are wrong, why not consider the possibility that the universe itself is older than 13.8 billion years? Gupta, by making changes to the Lambda CDM model, which is the standard cosmological model, has shown that if some physical constants have changed over time, the universe might be twice the age we estimate. It's interesting to know that Gupta's article caused quite a stir and was well received by the media, because after all, it's a sensational headline. But astronomers are skeptical about it, not because they want to cling to old theories, but because this new theory doesn't align with observations. Let's delve a little deeper into this topic. What we know so far is that the Lambda CDM model is the best model we currently have for the universe. Lambda refers to dark energy, which causes the expansion of the universe to accelerate more and more. CDM stands for cold dark matter, which moves very slowly and helps form galaxies and large cosmic structures. Therefore, this model suggests that the universe is made of these components. 5% is ordinary matter, like the things that make up stars, planets, and even ourselves. 27% is dark matter and 68% is dark energy, which causes the rapid expansion of the universe. At the same time, this model states that the age of the universe is 13.8 billion years, which aligns with many observations. However, considering recent discoveries, we know that this model is incomplete and needs revision. Now, Gupta has proposed a fundamental change to the Lambda CDM model to solve the problem of overly large galaxies in the early ages of the universe, which is based on this. First of all, he addresses the tired light theory. The tired light theory suggests that light gradually loses energy and its wavelength lengthens over its journey without the universe actually expanding. In other words, the idea of tired light is that as light travels through space, it gradually loses energy. Therefore, the redshift effect we observe from distant galaxies is not due to the expansion of the universe, but rather because of the reduction in the energy of light. Of course, this idea has a flaw. The problem is that if this theory were correct, the images of distant galaxies should be blurrier than those of nearby galaxies. However, what we observe from distant galaxies is that they have very good image clarity, just like closer galaxies. The next topic that Gupta raises is that the constants of nature might not be constant. In fact, he suggests that things like the speed of light, Planck's constant, and the gravitational constant might have changed over time. This means that the physical laws we are familiar with today might have been different in the past. However, this theory is probably not correct either. Now, why is that? Because firstly, no experiment has proven that the constants of nature change. Even precise studies on radioactive elements have shown that these constants have not changed significantly over the last 4 and 2 billion years. Secondly, if the universe were 26 billion years old, we should have found stars older than 14 billion years. But such a star has not yet been found. Thirdly, the oldest star clusters are about 13 billion years old, which aligns with the current cosmological model, not Gupta's model. Fourthly, perhaps those seemingly large galaxies are not actually that large. Maybe they are just very bright, and we are simply overestimating their mass. And finally, perhaps the galaxies are full of dust, and we are mistaking their red color for the redshift effect. So it is possible that the early galaxies are not so large as to cause problems, and therefore there might not be a need for a fundamental change in cosmological theories. What do you think? Do you think it's possible that the universe is actually twice as old as we thought? Or is the problem with our understanding of the early galaxies? Be sure to write your opinion in the comments. I would really love to know what your thoughts are, what you think.